Alrighty, we just wrapped up adding linear expressions. Now we're going to subtract linear expressions. So our first step is the same, to distribute if you need to. And then we're going to subtract each term in the second expression. So we're going to just recopy the first expression without any parentheses. But now I'm going to subtract 13y, and I'm going to subtract -7, right? We always include this symbol that's right in front of the term, so I'm going to subtract -7. Well, we know that in life and in math, if we ever have a double negative, it's really a positive, right? Taking away a negative is always positive in life and in math. So now I can circle my, I forgot a y, didn't I? Oh, I want that to be red. Here we go. There we go. Okay. I'm going to circle my y's. -5y and -13y make -18y. And then we just have 2 plus 7. 2 plus 7 is 9. That's in simplest form because there are no parentheses and no like terms. In the next one, I have some distributing to do over here before I start. So I'm going to do 3 times d, and I'm going to do 3 times 4.5, which I don't know what that is, and I don't have a phone or a calculator near me, so it is what it is, 13.5. And then I'm going to subtract both of these terms. I'm going to subtract 2d, and I'm going to subtract 4. I probably don't have to tell you that the most common mistake when subtracting expressions is students subtract the first one and forget that they're subtracting the second one, so they just put +4. Don't forget, when you're subtracting everything in the parentheses, so you're subtracting each individual term in the parentheses. Now I can combine like terms. 3d minus 2d is just 1d, and 13.5 minus 4 is 9.5. And that is simplified. Let's try another example. I'm going to recopy the first one without parentheses, and then I'm going to subtract the first term. So I'm subtracting -b and subtracting 12. Remember, if I have a double negative, I can change it to adding a positive. I always recopy it when I have that because I don't like to see that double negative. I don't know. The neighborhood dogs are going crazy, and Lily is just joining in. So there's lots of running up and down the stairs. Right now she's whining. Pretty soon she'll be all out barking. And I'm going to keep on going because I don't have time to do it until it's perfect. So then we have -3 and -12 together make -15. All right, here's another example where I'm going to distribute -3. So we're doing -3 times r and -3 times -2. So let me recopy this first one. And I'm going to do -3r and -3 times -2. So let's see what that shapes up to be over here. -3 times -2 is 6. Positive 6, right? I'm going to combine my like terms. I'm going to start with my variable terms. 4r minus 3r is 1r. Then I have -3 plus 6 is 3. Alrighty, and then the dreaded word problem. Dun, dun, dun. So here it says, the original price of a sweater is $M, and you buy it for M minus 3. You decorate the sweater and you sell it for 5M minus $7. So this second expression is more than the first one, because if you buy something and then sell it, you always sell it for more so you can make a profit. Write an expression that represents your earnings, right? That's the profit, that's how much money you make from buying and selling the sweater. So what you sold it for is more money than what you bought it for. So you sold it for 5M minus 7. We want to subtract what you spent on it, what you paid for it, to see how much money you make. So I'm going to take that first expression and I'm going to subtract each term in the second one. I'm going to subtract an m and subtract a -3. And I'll say it again. Anytime you subtract a negative, it's a positive. Now I can combine like terms. 5m minus m is 4m. And then we have our constant terms. -7 plus 3 is -4. And that's it, guys. You've made it through adding and subtracting linear expressions. Thanks for watching.